Hello everyone. Welcome to this training session on statistical data analysis using SPSS. My name is Vamsidhar. As a part of this session, I would be covering the analysis of various groups of data using the OLAP Cubes procedure of SPSS. OLAP actually stands for Online Analytical Processing. Basically, the major intention of this is to have a quick look at the key characteristics of the various groups of data. Key characteristics of the various groups of data. So summary, it's again a summarizing kind of a procedure, reporting kind of a procedure itself, wherein I can quickly observe the various calculations across the various groups of data, so that a quick key characteristics understanding can happen across the various groups. So just to quickly look at this process, it is primarily used for obtaining the summary statistics for the scale variables. So probably it's again a kind of a summarizing, not just on one variable. Probably for a good combination of the scale variables, I can summarize broken down by one or more grouping variables which are necessarily to be categorical variables itself. So it gives a multi-dimensional analysis. Multi-dimensional, not analysis, probably I call it as multi-dimensional summarization. It gives me a multi-dimensional summarization. So any number of grouping variables can be used separately, and any level or combination of the levels can be used for display. So it's more of a reporting kind of a tool rather than any statistical analysis on it. It's more from a reporting, more from a presentation standpoint rather than any kind of statistical analysis coming into it. So you can group all the variables. We'll even talk about the usage of pivot table, so that we can get the report of our liking by creating a pivot table here. So basically, as a case question, I would like to see summarize the key characteristics of high cholesterol versus low cholesterol people. So I would like to see in terms of age, or in terms of height, in terms of weight, or in terms of blood pressure, any of the other things. Is there any kind of a much difference between the high cholesterol people versus the low cholesterol people? Similarly, I would like to see between heavyweight versus normal weight people, is there any such kind of different characteristics that are existing? So from that standpoint itself, we'll try to use the OLAP procedures, and probably once we start executing it on our data, we can very well analyze. We can very well see how what the report that gets generated, and based on that we can try to analyze. All right. So let's get into the data. Okay, on this data, the same data whatever we have been using, we can start using the OLAP cubes procedure on this. So what we can simply go ahead with is, you start with analyze. The OLAP cubes is present under the reports category. So you go to this OLAP cubes on this reports category, and the summary variable should definitely be a scale variable. So probably if for the different groups I want to analyze, is there any age difference between high cholesterol people versus low cholesterol people? Is there any height difference, weight difference, waist difference? I would like to see all of them. The BP, right? And probably the BP diastolic, the cholesterol, obviously it's a high cholesterol people, so I'm not, or probably we can include the cholesterol also, the BMI, the leg length, the elbow, the wrist, the arm, whatever it is, right? Whatever the values I would like to observe between high cholesterol and low cholesterol people, as well as high weight and low weight, heavy weight versus normal weight people. So the grouping variables, which are the weight category, heavy weight versus the normal weight, as well as the high cholesterol versus the normal cholesterol. These two things, I take them as a grouping variable. So one thing you have to see as a part of the OLAP cube summarization, the summary variable should definitely be your scale variables. The grouping variables should be your categorical variables. So once I select them, I can get into the statistics part, wherein I can think of what all statistics I would like to compile for them. Probably mean and standard deviation are the most common ones, right? Why do I need the sum of all ages, and also probably I'll remove the sum, and probably if I want the percentages and all, simple numbers, number of cases, how many are there, the mean, standard deviation. But yes, you can look at each one of them. Probably you can go right from all those descriptive statistics which we were getting in our frequencies, procedure and all. You can very well obtain them through this also. But yes, quick look at mean and standard deviation should be sufficient for me. So I'll simply select only those two and I do a continue. And the most important thing is probably we can get it in a report form by going something like this. So in the title, probably I can go with the descriptive statistics, something like that. And this is the one. So grouped by, or probably grouped by cholesterol category as well as by weight category. So whatever are the groups I'm using, I can very well. So this is because it's a part of the report. I want the report to come out in a slightly detailed manner. So based on this, I'm saying okay. Once I'm doing it, if you see here, okay, once we are looking at the case processing summary, fair enough. You come here, the descriptive statistics. This is what is the heading which we have given. And in the at the bottom in the footnotes, you could see grouped by cholesterol category as well as by weight category, which is what is the title which we have given. So it's a report which can be generated by the way we have given it. And by default, you see the weight category is total, the cholesterol category is shown as total, which means initially it shows for all the 400 records. For all the 400 records, this is the mean age, this is the standard deviation in the age. For height, this is the mean height, this is the standard deviation in the height. Similarly, for BMI, this is the mean BMI, this is the standard deviation in the BMI. So, so if you are looking at it at a broad scale, so it is primarily showing the mean value and the standard deviation at a broad level. But I want to be more and more detailed. See, because I want to see how the differences exist across the various groups. Heavy weight versus normal weight. Is there any difference in age? Heavy weight versus normal weight. Is there any difference in the BMI levels? Heavy weight versus the normal weight. Is there any difference in their pulse rates? I'm more interested from that kind of a scenario. I'm not interested on a very high scale. That is where the way you can understand that part is you double click on it. Now this becomes a kind of a drop down. So probably here you can very well choose the categories, right? You can very well choose your category. Okay, overweight. Now overweight, there are 120 people. We have seen that out of 400 people in the overweight category, we have 120 people, and this is their mean and standard deviation. So probably if we are looking at total, you see here age 39 is the mean age, whereas when we are seeing total, 34 is the mean age. And if I am looking at normal people, only 32 looks like to be the mean age. So which means there is a clear cut difference in the mean age for overweight people versus the normal weight people. So such kind of a quick analysis can typically come out, right? And even if required, I can even pull out the median and those kind of calculations also, fair enough, right? So what you can very well do, if I want to look at even the median kind of thing also, I'll go into the statistics and probably I would include the median also apart from all these calculations. All right. So the same table. So this on an average, if I'm looking at age, the mean age is 34, whereas the median age is 32 for the overall data. BMI, the mean is 25.95, the median is 25.6. So you could very well see there are 400 records like that. Now when I am going with an overweight kind of a category, it is saying that the mean age is 39.11, whereas the median is 38. But for the BMI, I am seeing the overweight people have a BMI of 30.46, whereas the median is 29.69 and the standard deviation is 5.71. So some kind of an analysis is coming out from there, right? If I'm just looking at this, it shows that for overweight people and the cholesterol levels, for all cholesterol levels. So what you can very well see is you can create separate tables for each combination of the grouping variable. Now again you double click it if you want to see only for high cholesterol and overweight people. This is the average age, this is the standard deviation, or probably this is the BMI and this is the standard deviation. So but what I want is, I don't want to see for one group separately. Probably I want to look at a comparative analysis, right? So I want to expose all these variables side by side so that I can compare them in a much better manner. That is where I'll take the advantage of the pivot table. So by double clicking on it, I go to pivot and open the pivoting trace. And in the pivoting tray, what I will do is these two things. I will bring, let's say, let me bring this into this row category here. Now what you see is, now what you could see, probably you can play around with it. So you see normal versus overweight. Even if I am trying to bring the cholesterol here itself. You see here, now we will get a kind of and if possible, if required, what we can also do is the statistics. I can move into the layer if required. Okay, statistics, when I am moving it into the layer, I can compare one at a time now, right? Probably if required, let's say I want to look at the mean. For the mean, I am able to look at Okay, the mean age for normal people, and I mean for normal weight and normal cholesterol levels, the age is 31, whereas for normal weight and high cholesterol levels, the average age is 33. But for overweight, we are seeing 39 and 37. So such kind of quick analysis, or probably a much better way to look at, is one of the variables, let me take it into the column rather than maintaining both of them in the row. So this cholesterol, let's say I would like to take it into the column here so that it looks even more comfortable for analysis. So age, so these are the four numbers for me: 31, 39, 37, 33. So which means there is some kind of a difference that is existing, especially overweight people. Overweight is getting developed at a slightly higher age, whereas the cholesterols are even at a normal age itself. High cholesterol is coming even at a normal age. Same way you could see height, right? I'm not seeing much of a difference across these four, so no need to bother much. Whereas look at the weights for a normal weight, this is the typical range between the normal people and high cholesterol people. Whereas in case of overweight, these are the numbers. Waist sizes also you are seeing that for overweight people, the waist sizes are much higher compared to the normal weight people. Pulse rates, not too much of a difference, but you see the blood pressure for an overweight person, the blood pressures are looking somewhere between 125 to 121, whereas for a normal weight person, the averages are somewhere in the range of 109 and 110. Similarly, the blood pressure, diastolic pressure also is looking more like this. Cholesterol also we are seeing, in cholesterol, we are seeing the difference like this. Normal cholesterol levels for both normal and overweight people versus this. BMIs, we are seeing a very clear cut difference between the normal and overweight people. Leg length, I am not seeing much of a difference, right? And probably the L, or probably a small difference is existing in leg length, 39, 40, whereas this is 41 and 44. And wrist, arm. So you could very well do the comparison across multiple categories. Probably why only the mean. Now you could look at the standard deviation to analyze the consistency across. So these kind of things you can very well group the data on multiple dimensions and typically come out with the analysis. The presentation is much more comfortable when we are using the OLAP cube procedure. So just to summarize the usage of OLAP cubes procedure here, it is primarily used for summarizing the data itself, summarizing the scale variables based on the grouping of one or more categorical variable. And you can look at the categories as a combination, different combinations of the different categorical variables can be tried out for looking at the final outcome, or probably to do a comparative analysis between the various groups of categories. So that is what is primarily accomplished through your OLAP cubes procedure. So if you have any further queries regarding this, you can very well get back to me by giving me a call on the number that I have given below, or you can send in an email at vamsidhar@pacegurus.com. I can very well get back to you answering your queries. Thanks a lot for listening to this session. Thank you very much.